Hi, my name is Gordon Beaming, and in this video I'll be chatting to you about developing software for the modern world using only your browser and GitHub. A little bit about me: I'm a software developer for a company called Dorifco in South Africa, also a Microsoft MVP focusing on DevOps. If you happen to be watching this video before June 24th, 2021, just a quick mention of a talk that I'll be doing, which sort of builds on a lot of the concepts, if you will, from this talk on June 24th, where I'll be digging into features like dev containers and Dependabot to help you sort of take your software dev to the next level, if you will. But to get back to this talk, a quick overview. So I'll be taking a look at GitHub Codespaces. We'll be using .NET 5 and SQL 2019. Play a bit with LiveShare and see how that works when you are in GitHub Codespaces. We're going to build a Docker container, but largely for the purposes of dev and test. We're going to use some Azure CLI, Kubernetes, GitHub Actions, and then lots and lots and lots of PowerShell and YAML. So let's dive in. If you haven't heard of what GitHub Codespaces is, basically what it is a Visual Studio Code instance hosted for you in the cloud. So you're able to use what feels like just a normal VS Code, and I mean it is largely just a normal VS Code, but you don't have to sort of have it in your hardware. So you can, if you have access to a browser, you have access to your code and basically a full dev environment. So what specifically am I going to do in this little demo? We're going to go ahead and create a new repo. We'll open that repo then in GitHub Codespaces. We're going to create a new .NET 5 web app. And then we're going to simulate having some issues where we sort of need to ask a friend for some help with our apps and see what that sort of live share experience looks like. And then we're going to create a dev container for SQL Server. Okay, so diving in. So all the scripts that I'm using today are on in a repo called demos. The link will be in the end that you can access. For our repo name, I'm just going to go ahead and use the sort of default, or the default suggestion that GitHub gives us, which is glowing waffle, prepended with demo. I'm going to add a readme, choose the Visual Studio, git ignore, and then choose the MIT license, and then I'm going to go ahead and create this repo. Once the repo starts up, I'm going to go ahead and click on the sort of get code button, and I'm going to say open in Codespaces. As you can see, I have no Codespaces yet because this is a new repo. Go ahead and click open, new Codespace. Let's give it a little zoom in there quickly. The first thing you might notice is that this is a bluish green theme, and the reason for that is because Visual Studio Code, at least for me, syncs my settings with my GitHub settings. So that automatically brought in all my extensions that you might have seen on the left, as well as my preferences. So that scripts repo that I mentioned earlier, I'm going to go ahead and just pull that in. As you can see, I pulled that straight off my desktop into my browser, and now that forms part of my repo. So it's sort of the same dev experience that you'd have if you were running VS Code on your local machine. And I like using PowerShell, so I'm just going to use PowerShell instead of Bash inside VS Code. And then I'm going to head off to the sort of sample PS1 file that I have here that I'm going to use to be able to create or get started with creating my project. The first thing I want to do is just create a new git ignore using the one that that's templated out with .NET, and we'll overwrite the original one. And just so you know, You can see there that if you push F8, that runs the selected code, and F5 runs the whole file. Just so if you do see sort of magic voodoo running in the background, you know that I'm either pushing F5 or F8 to get that code going. It's a little diff there on the git ignore. Main changes is some extra bits in there for Mac and some VS Code bits at the bottom. So I'm going to go ahead and create the source folder and a web app folder quickly so that I can create my app in there. I'm going to create a new MVC app using C# with individual auth using .NET 5. And then I'm going to also say that I want to use local DB with the default has been SQLite, which I don't want to do. If I go ahead and do a .NET watch run, you can see that some of the ports that get exposed from inside the container pop up. And just a quick note here that for the HTTP port, which would be the 5000, you see it doesn't work. And the reason for that is because it ends up redirecting onto 5001, which doesn't quite work that well with the sort of reverse proxy that's running. But if you run the port of 5001 directly, you can see the reverse proxy runs perfectly fine, and I'm able to use access this URL. Something to note though, this URL is locked down to my GitHub user or your GitHub user if you're running this. You see there if I ran that in private mode, it does ask me to log in, and then just to show up front here, if I did run localhost 5001 directly, which is what you'd normally expect to work, it doesn't work. With the main reason there being, obviously this is running in a machine in the cloud at the moment. Okay, so next thing we can do, let's pretend I need some help. So I don't know a couple of things. One of them is that I don't know how to change the background color, so I'm going to ask for some help. So I've gone ahead here and said that I want to do a live share, so I have to give it access first. Like the VS Code instance needs to be authenticated, which I've just gone ahead and done. You can see I'm now auth, and now what I'm going to do is copy a link, for invitation link. This is one of the areas where I'm going to use not only the browser as I suggested with the demo, but that's just to simulate a friend joining the chat. So I've got VS Insiders installed. That's logged in with a user called DadaBot, and if I go ahead to live share and say join and paste in that that join link, you can see that in my Insiders side I've now joined a session, and on the left hand side, which is my normal experience, it mentions that I've joined that experience. You can see if I browse around in the left hand side, on the right instance, you can see the it's hopping around to wherever I'm browsing to, and that's because I'm following, like you automatically follow the person that you're joining the session for. So I'll go ahead and unfollow so long, and I'm going to sort of switch that follow around. So in my main instance, I'm going to say, well, follow the sort of guest instead of the guest following me. So you also notice there that there is shared servers. So I'm going to go ahead and launch one of those. And the first thing you might notice is that this launched on localhost 5001. It did prompt for a dev server, which I went and accepted. And now it is working with 5001. If I go and click that link that the bookmark there for 5001, you'll see that that also just works. So as part of this VS, well, the live share experience, it's proxying that code, well, proxying those requests from that machine in the cloud down to me on my machine, and then it's being exposed as a local port for me. So we'll go ahead and do some code changes. Very minor things. We're going to go and change the background color of the HTML on our page or site. We're going to go ahead and change it to green. So you can see on the guest side, I've gone and saved that file. Because we're doing a .NET Watch, everything will make sure that if it needs to be recompiled, it'll recompile. If it doesn't, it will just load. And And you can see there that in both the localhost 5001 and the GitHub preview link, they both took that change. On the right there, you can see the different terminals. So everything that happens for me as the user doing the live share, the terminal for that does sync through to the guest. So you really get a great experience as if you were over the shoulder. So you can see there now I've gone in as the guest on my local host 5001 link. I've tried to log in, and it says local DB not supported. Well, it's not can't be found. So I'm just going to go ahead quickly and check in the terminal as the guest, try to find out what's going on, and I'll come across okay, there it is, local DB is not supported on this platform. So at that point I was like, okay, I see what's wrong here. You're not pointing to the sort of proper dev SQL instance. So we're going to point that at localhost on port 1420. We're going to change the trusted connection to false, and we're going to go and add the user ID of SA and a password, which is the password that we use for our sort of development whenever we use this these scripts, which we're going to go and find sorry, in the local SQL Server PS1 file. You see it's a super secure and very strong password. We're going to go and paste that password in there. And now let's go see if that's changed anything for us. So we'll go ahead and run this again. And as you could probably expect, it's going to fail again. This time it takes a little bit longer. We can see that it broke again, and you can see the log was streaming through there telling us that it's broken. At this point, as the sort of guest, I'm sort of asking the other guy, like, hey, have you even created the local SQL? And the guy's like, no, actually I haven't. So now I'm going to go ahead and create that file. So you can see in the as the main account, I'm creating a new PowerShell terminal, and then I'm going to go ahead and pull down the SQL 2019 image just to like locally, and you can see as I'm running the scripts in the left hand side, it's showing on the right like exactly what I'm highlighting. The terminal's coming through, so you can, like, as the guest, you get that full experience. Again, it's as if I'm over the shoulder of the other person. Now I'm going to go ahead and create the directories for SQL, give the folders full permissions, and then go ahead and create that Docker container. I'll go ahead and refresh that again. It would not have worked because we killed the watch, so we just start that watch up again. It mentions again that there's ports, which, yeah, we know there's ports again. So if we go there, we'll see, okay, it says that we want to apply migrations. Now, normally you could just go ahead and click apply migrations, but as the guest, I'm like, no, we shouldn't do that. We have the snippet of code that we use instead. And the reason we do that is because when you go to production and you don't have this under the as in developer environment, you don't see that page for apply migrations. So instead what we do is at the end of the, I think it's the configure services method, we go and call initialize database, and that basically just under try catch says, like, basically try run that initial migration for us. So now if we go try log in again, you can see it says that there was an invalid login attempt. And for anyone that knows the default web app, basically what that's done for us is validated that it is actually able to call the database. Something that you might notice there is that all those terminals show as read-only, so you are able to change that. So you can say make a specific terminal a read-write, and that will allow the guests to type on their side and not only sort of be in a spectator mode. So we'll go ahead and just kill that live session quickly, return our zoom back up again just so we can see the text better for the rest of the demos. And we'll close that live session from our side as well. And that will close that up. Cool. So the next thing we're going to do, you saw in the previous one we built a SQL container, which we're using for dev purposes. But as part of, obviously, if we want this thing to go a little bit further, we're going to need to build a container for our web app as well. So if we're hosting this on containerized infrastructure, we're going to need our .NET Core app to be a container itself. So let's go ahead and see how we would go ahead and do that. For the demo, what we're going to do is the main objective is being able to run our Docker build. But in order to do that, we need to make sure that our sort of .NET restore, build, and publish functions work as expected, and the files get in the right places, and then we can run that Docker build. So I'm going to open up build.ps1, and we'll start off just by running the .NET restore, which should work as expected. Very simple stuff in this example, but it's things that you need to do to make sure it's going to work later on when you move into GitHub Actions, right? So we run our build, and our build works successfully, and then we run our publish, and our publish should work as well. And you can see in the top left hand corner there, an artifacts folder was created with a web app folder inside, and our binaries are in that folder. Our next step is to go ahead and use the Docker file that we have. So you see it's a very simple Docker file, which basically just copies stuff from that artifacts web app folder into an app folder in the container. And all we're going to do is move that Docker file straight into a build folder. Now that we've done that, we're going to return to our build PS1, and we're going to test that the Docker build does work for that file and our app. So we go ahead and run that command, and it should succeed, and there we go. So that succeeded perfectly fine, and we now know that our code is ready, and we could move with that in a pipeline. So we're going to go ahead and commit that code along, and then we can move on. Okay. The next bit that we're going to look at is the Azure CLI. So the Azure CLI lets you interact with lots of Azure services using the CLI, as you'd almost guess. So you don't need to go to do the APIs or an SDK. Everything just works really amazingly through the CLI. And because of that, it's going to enable us to do everything we need to do today from inside Visual Studio Code. Now, if you did go to the Azure portal, you are able to use the shell inside the Azure portal, and which will run Azure CLI itself. So again, you don't need a VS Code or Codespaces instance. If you just have your browser, you can go straight to the Azure portal and spin this off inside that environment. So we're specifically going to look at making sure our tooling is updated. So the by default, I think some flavors of Linux come with Azure CLI already, but the version that it comes with isn't the latest, and running a standard update on it doesn't always work. So I'll show you how you can do that update, basically a clean install of it. We're then going to go and create an AKS cluster. We're going to back up our SSH keys that's used in creating that cluster, or connecting to that cluster, and then we're going to create an Azure container registry. So the first thing we're going to do is just check what version we're on at the moment. So if we run that az-version, you can see it tells us that there is 2 updates available for us, and it suggests that we run AZ upgrade. But AZ upgrade gets to a point sometimes where it hangs. It's a known issue, and the sort of known way on, especially like this version that we're on at the moment, is to rather do the remove and then install fresh, which I'm going to go ahead and do, and then my life is going to be amazing. The next step is to log in, so we need to be able to know who we are, of course. So we're going to grab that code, head off to the login URL that's given to us. We paste the code in. The browser was already authenticated as me, so I can just click on myself and everything's okay. And now I'm authed, so I can close that. You can see it loads up my subscriptions. The next thing I'm going to do is just set my subscription to the one that I want to use for the demo, and then set some variables that we'll use later on. This demo does need 2 providers to be running. So I'm just going to go and get the status of those. You can see from that little zoom in that they are currently both registered. If that weren't for you, you could run the register commands underneath that. I then have a variables PS1, which just has a whole bunch of variables that get used throughout the demo in different scripts. And for convenience, I stored those sort of all in the same spot. So we'll go run that file with F5 just to get those all set. Next up, we're going to create the cluster. So we're going to first create the resource group, and then after that we're going to create the cluster in that resource group. So just highlight lines 1 and 2, push F8. You can see from that argument there at the end, I have comments out there, attach ACR. Obviously we haven't created our Azure Container Registry yet, so we can't attach that yet. The other thing you might notice there is we are saying generate SSH keys. So that'll get done for us. And from the output, you may have noticed that it told us that we should back up those SSH keys. So we're going to go ahead and do that because we don't want to lose access to our cluster if something would happen to our environment. So what this script does is it lists our storage accounts, just so we could check if we do have a storage account. We know we don't, so we also just going to go ahead and create a storage account. We're then going to list the accounts again, grab a storage key. Using that storage key, we're going to create a container, and then we're going to upload the 2 SSH files, the key and the public key, to the storage container. So you can see those last 2 lines there that's saying finished. That is the upload that is now complete. So the next bit that we want to do is create that Azure Container Registry, and pretty much similar to the other steps, we're going to call another AZ command. This time it's the AZ ACR create, and pass in a couple of args for that configuration. Again, capture that into a variable, and then set another variable for the ACR login server. After that, you can see we're running the AZ AKS update command. And what that's going to do is we're just going to tell it that we want to now attach ACR, and we're going to pass in the registry name that we've just gone ahead and created. In this demo, we're not going to need it, but if you did need it, there's the restore command to pull the SSH keys out of your storage and bring them, restore them back into your environment. Storing your keys in storage is probably not the best security advice, but for the purposes of backing it up outside of this environment, it works very well for a demo. Okay, so next up we have Kubernetes, and this part now where we start actually going ahead and using the bits that we created in the last section. So remember, we created the AKS cluster using the Azure CLI. So now we're going to go ahead and create that. Well, we'll put services into that cluster. So we're going to go ahead and create a SQL 2019 service, and we're going to use persistent volume claims to make sure that our data doesn't live only inside the container, because obviously if our service were to go down, that would then mean that we would lose data. And then the other thing we're going to do is create a web app service as well, which the app that we've created earlier will get deployed to. Okay, first thing we're going to do is look at the YAML file, which basically has a definition for persistent volume claim, and then our SQL deployment. You can see we're referencing our Azure container registry, and then in this script, basically what we're doing is we first importing the SQL 2019 container to our cluster. We're then going ahead and applying the YAML for the persistent volume claim. We're then going to do some checks, which we're not going to check them ourselves in this case because I know this works. But generally you'd want to run this line by line, make sure that everything works as expected. We then create some secrets for SQL for our passwords, and then apply the SQL deployments. And then we want to make sure that we check the pods until the status is running, so we know it's running. Again, I'm popping out of the browser here, and that's just because it's easier to show you the SQL connection working. When we did a get service, we got the external IP address there, and we're now going to connect to it from Azure Data Studio, just so you can see that this is a normal SQL instance that's running as you'd expect it is, but it's more just to double check and make sure there's no sort of voodoo happening under the cover, or maybe there is. Cool. So I'll go ahead and create a new query, and in that query we're just going to select all the databases that exist, just so we can see what currently exists on here. There's no sort of magical side load thing of our production database. You can see it loads the 4 default databases. We'll go ahead and create a new database called testdb, and then run our select again, just to show that everything works as expected. Regular database, regular things, nothing surprising here. Okay. So next up, we have our website's YAML file. Again, very similar to the SQL one, we're also pulling off our local ACR. We're using the SQL connection to populate environment variables, and then our PowerShell script pretty much does the same thing. We apply that YAML file. We then wait for the status of that to be running, which in our case is not going to be running. Spoiler alert, because the container that we want doesn't exist. So we told it to use the web app container, and web app container doesn't exist currently in our ACR, so we'll go and do that in the next section. So now we move on to GitHub Actions. So GitHub Actions are pretty amazing. So the technology is very similar to Azure Pipelines. The one epic thing with GitHub Actions is you can trigger off any event, or any GitHub event. So think about your standard ones like a code push or new PR. But then there's also other things like anytime a branch is deleted or an issue is created, or maybe it's anytime any of them are edited or even deleted. You can trigger your actions, as well as obviously the common things like scheduled and manual triggers. For the action, it's pretty simple. We're going to build our code. We're going to package that code using the Docker file, and then we're going to deploy it straight into our Kubernetes cluster. So we start off and go and create a new workflow. You can see it's amazing. If you put a full path, it goes and creates that whole path for you. So there's our workflow file. Again, go to the sample scripts and grab the whole script for that workflow. If we just take a step through this and take a look what it looks like. So we've got our name at the top, build and publish. This will trigger off a push to the main branch. We'll run this on Ubuntu latest. You can see that we start off by updating a version using some information that's available as part of the build run. So as part of this, I'm going to need to just go and grab this version tag and update my project file. So we can go and add this version tag there, and it's just saying that we use as sort of a find and replace as part of the build. We then run that restore, build, and publish command, similar to what we ran when we did the Docker file part. And then we run a bunch of other commands. So you can see there's the Azure login with Azure CLI. We then build our Docker file, and then we push to our Azure Container Registry. Very similar build command, except that we're tagging it with more things now, and then we deploy to the cluster as you'd expect at the end. So we don't have a bunch of environments like we potentially should. We don't have any gates at the moment. This is basically just one file that says any commit to main, try and get this out the door. So yeah, we've got a Kate's PS1, and we're going to run this. The first thing it does is creates a service principal for us in Azure, and then using that service principal and a bunch of other information that we've built up so far in the demo, I write out a bunch of variables that we need to go ahead and create as secrets in our GitHub repo. So you can see I grabbed the name there, Azure credential, grab the value, drop it in the value, add that secret, and then we're going to go ahead and do the same for all the others. So if you want to see what all of those look like, again, the scripts are available, but I'm just going to run this quickly just to save us some time, because clicking slowly takes long. Okay, so next up, what do we need to do next? We should just need to commit this. So we're going to go and commit this, adding that we added actions, and as soon as we this commit gets to GitHub, so we'll go and push this as well, it should automatically kick off our workflow for us. So let's go see what that looks like. So if we go to actions, we can see this running. Now, something I didn't realize is that somewhere while I was busy committing code, I accidentally reverted the Docker file change that we made earlier on. So this whole build runs nice and fine, and then it gets to the part where it says and build, and then it says, sorry, that Docker file doesn't exist. So you can see there it says, oh no, that step broke. If we go and interrogate that step, we can see there that it says that that file does not exist for us. So we're going to go back to our Codespace. If we look inside the build folder, we can see it's not there, which was very weird. So we'll just go and copy it back in. So we'll open up the app setup, and then we'll grab that Docker file, move it back to the build file or build folder, and then we're just going to commit that again. If I could type properly, I would say Docker instead of what the screen said. And cool, so now we've pushed that up, and let's go and see what that looks like. Okay, so we head off to Actions again. You can see the Docker file commits is running, and if we open up that workflow, you can see it's all running the same way as it did last time. This time it should succeed. There is an error there, but that's more of it's an infrastructure thing. It doesn't really impact us. So we're just going to move on and not really worry about that. So now if we go and get the pod, you can see that it's running for the website. So remember earlier it gave us an error, and now if we get service and we get that external IP, we should be able to browse to that external IP, and our website loads as we would expect. And now if we go and log in, it should just work as expected. So you can see it says invalid login attempt, which from when we did the original demo, you can remember that then means that it does have access to the database. And if we query all the databases, you can see that we do in fact have that demo prod running. And just as a final thing to make sure it is for reals there, we open up and we can see the tables in that database. So it did actually work as we expected, and this is now running inside our Kubernetes cluster inside Azure. Okay, now the thing that always bites me, especially when I play around with Azure CLI, is that I don't clean up resources. Once found it really amusing when Azure CLI first came out. Well, actually not when it first came out. When it first came out that you could do this from your mobile phone. And I started showing everyone how awesome it was that you could just create new clusters from your mobile device. Now, when you're typing everything fresh from your phone, you don't really put in all the parameters that limit the size of the cluster that you create. So I had created a couple of moderately beastie clusters that were eating away at my credits, and I had forgot them like that for a week, so it really put me on rations for the rest of that cycle. So let's see how we would go ahead and clean up the stuff that we created today. And it's really quite simple. We're going to remove an Azure resource group, which is a single command. And that's going to tear down every bit of infrastructure we spent so long putting together today. And then the last thing we'll do is remove the GitHub Codespace. So quickly before we do that though, I realized I didn't show you what the resources look like in the Azure portal. So here's the Azure portal. Surprise, surprise. Everything exists here as you'd expect. So if we go to our repositories, you'll see there's server and web app, which is the things that we publish. So remember, the second build worked and the first didn't, so we've got the 19.2 and not 19.1. And then if we look at the workloads, you can see that our MS SQL inst and our Azure websites are there. There is 2 instances of the Azure website running, or 2 replicas, should I say. And now we're going to go and get rid of all that hard work. So we're going to run az group delete, pass in the resource group name, auto respond yes, and we're going to tell it that we don't want to wait, because obviously the teardown for that does take quite a while, but we're not going to hang around and watch that. So to show one extra thing with Codespaces quickly, I'm going to just go and add a extra random commit inside the container. And then we're going to head out to GitHub and just go and look at the like how GitHub shows us that information. So if we click to go to the repo and we go to open with Codespaces and we click on settings, you can see it already in that screen, but you can see it shows you how many commits the code that's in that space is behind or ahead. And from the portal, you can also say export your changes to a branch, so that'll take like the current state from inside the code space and export that. And you saw when we tried to delete it, it said to us, are you sure you want to do this? Because there's actually changes inside that code space that haven't been committed yet. Okay. So you might be asking, what next, right? So we sort of did a lightning run through a lot of stuff there. And a lot of it's not sort of optimal to sort of modern day best practices. So things that you could look at, if any of this interests you, things you would want to look at next as sort of a natural progression, is looking at the Azure ARM templates. So that will allow you to define what your Azure infrastructure looks like. So instead of you running a whole bunch of Azure CLI commands, you'll have an ARM template that describes what your Azure resources should look like, and you'll basically do an apply with that template to your Azure subscription, and then everything will be spooled up for you. The other thing that you'd want to look at for Kubernetes is Helm. So you'd want to be, instead of manually, like with PowerShell, creating your individual services, similar to the ARM templates for Azure, you're going to be building Helm charts to build up what your services and deployments look like inside your Kubernetes cluster. And then we today accessed our cluster, our web apps, or the web app through the external IP. So you want to go look up the HTTPS ingress controllers for Kubernetes, especially if you're using Azure Kubernetes. And then, slightly pointless today, we're using a tech which helps you a lot with redundancy. Something that I didn't show you or specifically mention, but I suppose I could mention now, is that the SQL that we had set up, if we had deleted the pod, or the pod had gone faulty, it would have sort of restarted itself. Sorry, not the pod, the service would have restarted itself and sort of almost hydrated itself, if you will. Not really hydrate, but reattached to its storage, because we're using a persisted volume mount. And we would have been in a good space. The problem with today's demo is we had one thing for everything to run on. So you want to go look at, obviously, setting up your Kubernetes cluster properly, especially if it's for production workloads, that you do have zone redundancy, so that your workloads theoretically should never then go down. For your sort of dev and test scenarios, you want to go look at Azure Dev Spaces. I think that is being replaced by Bridge to Kubernetes. The lifespan of that is still quite far out. So I think it's until October 2023 that you have for Azure Dev Spaces. But yeah, you want to go look at that. And then you want to look into more, or as you probably guessed it, any quality gates. So today I didn't have unit tests. I didn't have any sort of integration tests to verify that anything worked. We just built, packaged, and deployed straight into production. A very risky scenario, but as you could see today, everything worked. So if things are working, is it actually that bad? Yeah, the answer to that is yes. You definitely don't want to be doing that. And then some resources. So I mentioned the demo script repo, so there's a short link that will go off to that. Otherwise you could just browse to my GitHub account, and it should be one of the pinned repos. And then there's a couple of resources there that you can access as well for the various things that we spoke about. And then, yeah, if you have any questions, please leave them in the comments or ping me on Twitter, LinkedIn, or you can go to beaming.dev to see where else you can find me on the interwebs. Thanks. Cheers.